NASA found something that honestly sounds made up. A planet, out there, right now, that checks almost every single box scientists have spent decades looking for. The right size, the right distance from its star, the right chemicals in its atmosphere. A planet that, at least on paper, looks more suitable for life than Earth does in some ways. Its name is K218b. And the reason this matters isn't just because it's a cool discovery, it's because of what it implies. Because if a planet this well-suited for life exists, and we're already pointing our best telescope at it, then the question stops being, is there life out there? And becomes something much more uncomfortable. Why haven't we seen it yet? That's what we're going to get into today. Before we get into K218b specifically, we need to understand what scientists are actually looking for when they call a planet habitable. Because habitable doesn't mean paradise. It doesn't mean you'd want to move there. It just means this place probably won't kill everything immediately. The first thing scientists look at is distance from the star. Sounds simple, but get it even slightly wrong and you're in serious trouble. Too close? You end up like Venus. Venus is basically Earth's evil twin, same size, similar composition, but it sits too close to the sun. Surface temperatures around 465 degrees Celsius, a crushing atmosphere, and air that's mostly sulfuric acid. Nothing we know of survives that. Too far? You get Mars. Mars is cold, thin on atmosphere, and the water that might have once existed there is now frozen or gone. Without liquid water on the surface, life as we understand it just doesn't get started. So there's this narrow band around every star, not too hot, not too cold, where liquid water can actually exist on a planet's surface without instantly boiling off or freezing solid. Scientists call this the habitable zone, sometimes the Goldilocks Zone. But, and this is the part people often skip over, being in the habitable zone is just the starting point. It's the minimum requirement, not the finish line. A truly habitable planet also needs a stable atmosphere to regulate temperature. It needs some kind of protection against radiation from its star. For a long time, all of this was just theory. We knew planets like this should exist. We just couldn't see them clearly enough to know for sure. Then everything changed. The James Webb Space Telescope launched in December 2021, and it changed what's actually possible in this field. Webb doesn't just take pretty pictures of distant objects. It does something more useful for our purposes. It reads light. Here's how that works. When a planet passes in front of its star, what astronomers call a transit, a tiny fraction of the star's light filters through the planet's atmosphere on its way to us. As that light passes through, the different gases in the atmosphere absorb different wavelengths. So by the time that light reaches Webb's instruments, it carries a chemical fingerprint of whatever's in that atmosphere. It's like holding a glass of water up to a light and being able to tell not just that there's water in it, but what else is dissolved in there, without ever touching the glass. This means, for the first time, we can analyze the air of a world 120 light-years away without ever leaving our solar system. And that's when K218b got really interesting. K218b is an exoplanet, meaning it orbits a star that isn't our sun. That star is a red dwarf called K218, sitting about 120 light-years away in the constellation Leo. The planet was first discovered in 2015, but it wasn't until Webb turned its instruments toward it in 2023 that things got genuinely strange. Let's start with the basics. K218b is about 2.6 times the size of Earth, putting it in a category called a sub-Neptune, or possibly a Hycean world, a class of planet that some scientists think could be covered by a deep liquid water ocean under a hydrogen-rich atmosphere. Its size means gravity would be stronger than Earth's, but not crushingly so, not in the range that would make life impossible. In 2023, the James Webb Space Telescope confirmed the presence of methane and carbon dioxide in K218b's atmosphere. It also found a significant lack of ammonia, which is exactly what you'd expect if there were a liquid water layer beneath that atmosphere, because ammonia dissolves readily in water. And then there's the molecule that scientists are still being careful about, dimethyl sulfide, or DMS. On Earth, DMS is only produced by living things, specifically marine phytoplankton. The Webb data showed a possible signal for DMS in K218b's atmosphere. The scientists who published this were careful to call it a tentative detection, requiring further confirmation. But they published it. Because even a possible signal for a molecule that only life produces, on a planet already ticking so many boxes, is worth paying attention to. Now, none of this individually is proof of life. Methane can come from volcanoes. Carbon dioxide exists on plenty of dead worlds. Even DMS could, in theory, have an exotic non-biological explanation we haven't figured out yet. But here's the problem. On Earth, methane and carbon dioxide coexist in our atmosphere because life constantly replenishes them. Chemically, they react with each other and break down. Left alone, without something continuously producing them, they disappear. The fact that they're both present on K218b in a seemingly stable balance suggests something is maintaining that balance. On Earth, that something is life. So what's doing it on K218b? Here's where we have to stop and deal with the uncomfortable reality. K218b is 120 light-years away. That sounds like a measurement. It doesn't really land until you think about what it means. 1 light-year is the distance light travels in a single year, moving at 300,000 kilometers per second. Light covers that ground in a year. We do not. The fastest spacecraft humanity has ever launched is the Parker Solar Probe, which at its peak reaches roughly 690,000 kilometers per hour. That sounds fast. It's the fastest thing we've ever built. At that speed, it would take approximately 2 million years to reach K218b. That's not a number we can engineer around. That's not a problem future technology will probably solve in a generation or two. Our entire recorded human history, every civilization, every empire, every war and discovery and invention fits inside roughly 5,000 years. A trip to K218b at our fastest speed would take 400 times that, so we are not going there. Not us, not our children, not any generation we can meaningfully imagine. What that means is this: K218b is not a destination. It is a mirror. We can only look at it from here, analyzing the light it lets us borrow, trying to read its secrets from across an effectively uncrossable distance. And the more we study it, the more unsettling the view gets. K218b might be older than the conditions that allowed life on Earth. So where does that leave us? We found a planet that fits the profile better than almost anything we've ever seen. It has the right position, the right chemistry, the right atmospheric signals. The James Webb Space Telescope, the most powerful observatory humanity has ever built, is pointing at it, and what it's reading back is strange and suggestive and deeply inconclusive. We can't go there. We can't send a probe there in any time frame that matters to anyone alive today or for many generations after. We can only watch. And watching has a way of forcing questions that we're not ready to answer. If something is alive on K218b, it's been alive potentially longer than complex life has existed on Earth. If it evolved intelligence, it may have had time to evolve things we can't conceptualize. And if it ever looked toward our corner of the galaxy, well, for most of Earth's history, there was nothing here worth noticing. Simple bacteria for billions of years, complex animals for a few 100 million, humans for a geological eye blink. Maybe they looked and moved on. Maybe they're still looking. Maybe the search goes both ways, and we just don't know it yet. K218b started as a scientific curiosity, a distant world with interesting numbers attached to it. It's becoming something else, a question about who we are, how long we've been here relative to everything else, and whether the universe we're only beginning to explore has already been explored by someone else, long before we knew to look up. We just keep watching, because right now, that's all we can do. And honestly, the watching alone is enough to make you lose sleep.